Hello, my name is Kiran Kumar. I'm your physics lecturer. Today topic is fundamental frequency of the stretched string. Welcome to my channel Nature of Physics and Art. See, considering L is the length of the stretched string between the two rigid supports, and due to the small vertical jerk the wire get vibrate and form the one loop wavelength is lambda by 2 between the two nodes, and center is antinode will be formed. See, now we will discuss the fundamental frequency of the stretched string. Here L is the length of the string and wavelength is lambda by 2. Okay, see, here first I am going to write length of the string, that is lambda by L is equal to lambda by 2, and wavelength lambda is equal to L. From the given equation, L is equal to lambda by 2. Try to understand. Okay, see now, next fundamental frequency mu, we are going to write mu, which is equal to V by lambda. Okay, now V is equal root over T by mu whole divided by lambda is equal to L, and rearranging the equation, mu is equal 1 by 2L root over T by mu. This is the fundamental frequency of the stretched string of the wire or string. Okay, V is equal velocity of the transfer wave, that is equal to root over T by mu. We can write here V, which is equal to root over T by mu, that is velocity of the transfer wave. Okay, so finally we got the fundamental frequency of the stretched string. Mu is equal to 1 by 2L root over T by mu, and step by step we will discuss the relations based on the fundamental frequency. See, first one is here Young modules. I am going to write Young modules, which is equal to F by A whole divided by small l by capital L, where F by A is the stress, L by L is the strain. Okay, so small l is the length, that is elongation, capital L is the initial length. Here F by A is the stress area, that is force per unit area. Okay, see, now rearranging the equation, I am going to write the force equation. So F, which is equal to Y into A small l divided by capital L. Okay, see, here F is the force, we can write as tension also force, tension is a force, F, and fundamental frequency 1 by 2L root over T by mu. T value I am going to replace here F, it is YA small l divided by capital L whole divided by mu. Okay, here we can write mu is the linear mass density. Okay, then next I'm going to explain the second relation. Here mu is the linear mass density, that is mass by length, which is equal to mass is rho V. So we can write rho is equal to m by V, and mass is equal to rho V, and mu, which is equal to rho into here divided by L. Rho V is equal to, we can write area into length. Okay, so that is AL divided by L, and LL get cancelled here, so we got mu is equal to rho A, that is A is the area of the wire, or we can write area is equal to pi r square. Then mu is equal rho into pi r square. Okay, listen to me. This value is replacing in the above equation fundamental frequency. Then fundamental frequency mu, which is equal to 1 by 2L root over, so we can replace here capital L instead of small l, because of small l is taken as here elongation. Okay, otherwise we can change in the next, in the fundamental frequency, that is small l is equal capital L. Here mu is equal 1 by 2L root over T divided by, instead of mu I am writing rho into A, or another step we can write mu is equal 1 by 2L root over T divided by rho into pi r square. This is the second relation for the fundamental frequency. Here we are replacing the linear mass density. Please copy this. Already we did two relation. Now third relation, in which we will replace the tension as well as the linear mass density. See here, fundamental frequency mu, which is equal to 1 by 2L root over T. T is equal tension. Tension is a force. Force we can write here YA small l divided by capital L whole divided by, here mu is equal to rho A. And rearranging the equation, AA get cancelled. Here mu is equal to 1 by 2L root over Y into small l divided by rho into capital L. Okay, see here again we can replace here small l by capital L is equal to, that is alpha into delta t. Here alpha is the coefficient of linear expansion and delta t is the change in temperature, and we are replacing in the above equation mu is equal to 1 by 2L root over Y by rho into small l by capital L value is alpha into delta t. See, alpha into delta t. Here small l by capital L is strain. Okay, then continuation we can write the relations. Based on this we got the fundamental frequency of the stretched string. Very useful relations. Please copy this. Now one example problem. See, two vibrating strings of the same material but of length L and 2L have radius 2R and R respectively. Then they are stretched under the same tension. Both the strings vibrate in their fundamental modes. The one of the length with frequency mu1 and other is mu2. The ratio of the mu1 by mu2 is given by. Find out. This is 2000 JEE mains question. Sorry, advanced question. First, I am going to write given values. See here. Now the values, that is given tension is constant and also frequency constant, and here length initially to L given, for corresponding frequency is mu1, and 2L length corresponding frequency is mu2, and here radius also given. For mu1 frequency radius is given as 2R and mu2 radius is given as R. So the fundamental frequency of the stretched string mu, which is equal to 1 by 2L root over T by mu here. See here T is equal to constant, mu is equal to rho into pi r square, that is area rho into A. See mu, which is equal to 1 by 2L root over t divided by rho into pi r square. Try to understand here. Mu is inversely proportional to the length and also inversely proportional to the radius, because of here square root of cancel for the radius. Okay, so here we got mu1 by mu2, mu1 by mu2, which is equal to, we can write L2R2 divided by L1R1. So here the values are given based on the relation mu1 by mu2, which is equal to L2 is 2L and is L, and R2 which is taken as R, and R1 is taken as 2R. Here R and LL 2 get cancelled, then answer is mu1 by mu2, which is equal to 1 is our answer. Please copy this. Now second example, see. The sonometer is set on a floor of a lift. When the lift is at rest, the sonometer wire vibrate with fundamental frequency 256 Hz. When the lift goes up with an acceleration a is equal to 9g by 16, the frequency of the vibrating of same wire changed to. See here in this question, fundamental frequency on the rest of the floor is given of the vibrating string, and we have to find lift to moving upward direction, then fundamental frequency. See here, step by step we can discuss. First, fundamental frequency mu is equal to 1 by 2L root over T by mu. Here T is the tension, that is a force is equal to F here, and F is equal to mg. Try to understand. Mu is equal to 1 by 2L root over mg divided by mu, and mu is directly proportional to the square root of g here. And see, we can write the relation mu1 by mu2, which is equal to root over g1 by g2. Okay, see here g1 by g2 represent accelerations for the frequency mu1 and mu2. Now we can write mu1 is equal to 256 Hz given. So here I'm observing, that is mu1 must be 256 Hz given, and here mu2 we have to find, and g1 is equal to g only, that is a lift at rest on the floor, so g1 is equal g, and g2 we have to write, g2 is equal lift moving upward direction, that's why g plus a. So here rest g1 is equal g, lift moving up, that's why g plus a. We can write here g2 which is equal to g plus a value is 9g divided by 16 given in the question. These values are replacing in the above equation. Mu1 by 1 is replacing 256 Hz divided by mu2, which is equal to root over g1 is g and g2 is g plus 9g divided by 16. In numerator and also denominator, g is common and cancel. See here, numerator g and denominator g common and cancel. See now, that is 256 by mu2, which is equal to root over, here the value is root over 16 divided by denominator value is 25 after calculation. See now we can write mu2 divided by 256 is equal to 5 divided by 4. Now mu2 which is equal to 256 into 5 divided by 4. After calculation, we will get fundamental frequency when the lift moving upward direction with an acceleration a, that frequency mu after calculation mu2, that is equal to 320 Hz. Please copy this